Okay, tell me your doubt. So I think you have doubts, so we can discuss. So where should I start? Should I start with this last question, sixth one?
Hi, sir.
Okay. So sixth is actually consider three random variable x, y, z where so z is uniform 0, 1, and for any given value of z, the other two random variable x, y are independent. So they want to say x given z and y given z are independent. Okay. So these two information are given, and identically distributed normal z1. Oh, so means x given z is equal to z and y given capital Z is equal to z, add IID normal z comma 1. They have given you this. Okay. And z is uniform 0, 1. Now, so verify whether xy are independent. So do you think xy will be independent? That is, you have to check.
Yes.
So how will you check xy are independent or not? So you have to find the joint of x and y. So f of x given z, y given z, x, y will be PDF of है ना x given z in x and PDF of y given z है ना in y. Okay, they have given they are independent. Using this, can we find this f of x comma y x y? How to find this probability? So I think we should go with probability. Okay, so better is to take the CDF. So take the CDF. If I ask you f of xy, uh, yeah, xy, capital X less than equal to x, capital Y less than equal to y. So can we write using theorem of total probability? Can we write it PDF of z into CDF of xy, x less than equal to x, y less than equal to y given z is. Can we write like this? Theorem of total probability. Check. You know, probability of event A is summation probability of EI into A given EI. है ना? When EI are discrete actually. So I is discrete, na? So when it is continuous, you can write like this.
Okay.
Okay, use this. So and Z will be what? 0 to 1. So 0 to 1, it is 1. And since x given z, y given z are independent, है ना? So this will become, it's a CDF. So now what can you do? If you integrate it, will you get this? I was finding joint CDF of xy, and can we integrate it now? So I think this PDF we already have, don't we have? We have, na? It is actually normal
Normal
z1.
set.
Okay, so can you put it? So instead of taking CDF, if we take PDF, what will happen? Okay, put it. So what will happen? So it is actually 0 to 1. It will be minus infinity to x PDF of this. Okay. So you have to solve this integration. So you can write the PDF 1 by root under 2 pi e की power minus half z square dz. Uh, it's a norm mu is z na. Oh sorry. So mu is z is like x minus z dx. Is it? PDF of normal z1 and into 0 minus infinity to, or instead of x you can take some u if you want u, and 1 by root under 2 pi e raised to power minus half v minus z dv, and now after all we will have dz. So this is the thing you need to solve.
Okay, sir. In the PDF e raised to minus 1 by 2, u minus z the whole square is there, right?
Uh-huh. Yeah,
Normal distribution PDF.
I think I missed a square. Okay.
Okay.
Yeah, so you have to integrate it. So it is not integrable function. Directly you cannot integrate.
Okay, okay.
So the other way can be, mm, you can take a joint, double integration. So double integration thing, or you can differentiate it with respect to, yes, z will vanish actually. So the question is, joint PDF of xy will be joint PDF of marginal of x and y, that we are trying actually. That you need to think. Can we integrate it? I think it is complicated. So there might be some easier way. Okay, think of some easier way. If you can integrate this, then it is done. But integration is not much easy.
Yes, sir.
Oh, you can have intuition. So do you think it will be normal? Z is 0 to 1 only, right? Normal Z1. So x given Z independent y given Z. And it's a kind of triple integration, you know, it's a kind of triple integration. One is minus infinity to y, minus infinity to x, 0 to 1. So this is kind of this, but this is a lengthy one, I think. Du you can keep later. So du dv. So first is dv, then du, then dz. Okay. So it is like this. And if you can solve it, then it will be easy. But this is a difficult way. So let's try some easier way. So I think they are independent. So it seems it will not be something. Question is, will it be just function of x into function of y? It is. So we are what we are trying. We are trying x comma y, xy. Xy we don't know. What is x comma y? So will it be some CDF of x at x, CDF of y at y? The question is this. So after integrating, do you think x will be separated and y will be separate? So here is z involved, and here is z involved. Z is okay. Here is just u. So you will integrate this with first respect to v, and then after that you will integrate this with respect to u. Okay, z will be left. Then do you think this will come like this? Or what I was trying initially. So I did with CDF. Okay, so we could have done with PDF that initially I was trying. So f of xy is also you can do. This is called convolution method, I think. So f of z this into f of x given z, since they are independent, na? So just I'm opening, and f of y given z, just it is joint actually, but I'm opening because they are independent. Y dz 0 to 1, and z was here, z was uniform 0 1. So this can also be done. So now the question is, if you integrate, do you think it will give you this? The question is this actually. So do you think z will vanish and it will make a product? So now you can write the PDF. I think here you may integrate. Let's try. So it's a 0 to 1. PDF is 1. And this PDF was what? This was 1 by root 2 pi e raised to power minus half. It was z na normal, so x minus z.
Z the whole square.
Yeah, whole square. 1 by root 2 pi e raised to power minus half y minus z whole square dz. Now can you integrate? So again the question, so this is easier one, na? Integrating this is easier than this. This was much complicated. This is easier. Now the question is again you have to integrate with respect to z.
Okay.
So you just open it, I think a minus b whole square, a minus b whole square you do and collect the terms. Or you just take 1 by 2 pi outside 0 to 1 e raised to power minus half x minus z whole square y minus z whole square dz. This is the thing. The question is, or other way you can do one thing or more. So can we find covariance between x, y? So if we don't go this way, we have to check x, y are independent or not. So first attempt we tried. This led to very difficult way. We left. Second attempt was this. I think this is also complicated. We left. Now third attempt we are trying in other way. So what can we write this? Covariance of x, y.
Expectation of xy minus.
Okay, so you go this way. So you can go this way, no problem. Ex, ey, right?
Yeah.
And that you can write given z thing. So if you write given z thing, what will happen? So can we write this as a double expectation of xy given z, and here we can write e of x given z, here e of y given z.
Yes, sir.
Now since x given z, y given z are independent, so that will be separated. So it will be x given z here and y given z here. And since x given z is normal, what is normal? X given z is normal, z
Z1.
normal z1. So mean will be z.
Z.
It is z. Okay. So now uh, expectation, this is what? Z into z minus expectation z whole square. This is kind of variance of
Variance of
z, which is
expectation.
1 by 12. This is a better way. Hai na? This is positive. So when covariance is positive, what can you say? Is it independent? Can we say x and y are independent? Yes or
No,
no?
no.
So you know, है ना? So covariance between xy is non-zero. This guarantees x and y are not independent. है ना? We know
Okay.
if they are. So this is the solution. So this is the correct way to do first part.
Okay, sir.
Okay. So first part we have done this way, and this is the correct way. So that we were just checking. So we had given that x given z and y given z are independent, and we were checking whether x and y are independent. So answer is no. X and y are not
Okay.
independent. So this is the first part. Yeah. Second part also.
Yes, sir.
Okay. So now you know what? We have given here that so in the second part, if we try, okay, so we can try second part.